Hello, algebra students. This period is being made specifically for 8th and ninth period, my honors classes. However, in a couple of days, the level 2 kids might be watching it. So I'll just say hello, algebra students. Mr. Lawrence here. Unfortunately, I couldn't be with you. My back started acting up Thursday afternoon, and Friday morning it got worse. So I'm going to go see a doctor today, hopefully. By the way, math counts, kids. I am still planning on being at the competition, so don't worry about that. All right, let's get down to business here. We know how to solve systems by graphing. We know how to solve systems by substitution. There is another method called elimination. Now, when I was a kid, I thought elimination was the bomb because there are some elimination problems that are so simple. Like number one here, when I get ready to do number one, it is so simple that I used to love to use it all the time. Now that I am much more seasoned and much more experienced, I tend to only use elimination when they are simple. I find I make less mistakes using substitution. I want to warn you, because that's the way I thought about it. Don't think elimination is always the easiest way. It's not. It's good to have more than one way to attack a problem. There are some situations where I always do an elimination, but if it's not an easy elimination situation, I do it by substitution. All right, so let's get down to it now that I've given you my 2 cents on the problem. All right, by the way, remember, you should be taking notes on this video and trying problems with me. All right, so for problem number one here, if we were doing a substitution, we would isolate one of these variables, right? But I notice I have a positive y and a negative y. What would happen if I add, that was strange, a little lag going on. I add these two equations together. Watch. I'm getting x plus x, which is 2x, of course. Don't you dare try to tell me it's x. 2 plus 4 is 6. Look at that, the y's canceled out. Now I just have one variable. I'm going to divide by 2. And so therefore x equals 3. I just found the place where the x-coordinate of the place where the two lines intersect. Now, one of the reasons I don't like elimination as much as substitution is, in substitution you do your hard work first and the easy work second. While in elimination it's kind of reverse, kind of. So now I'm going to take one of these two equations. I'll take x plus, sorry, I got a lot of lag here going on. It's driving me crazy. X plus y equals 2. I'll substitute 3 in for x because I just found out that x equals 3. And then I'll solve for y and get y equals -1. And so the two lines intersect at 3, -1. And there you go. Okay, and again, you guys are like, whoa, my gosh, that's easy. Well, that's a very simple one. Okay, number two. People teach elimination differently. I always teach it from the perspective of adding. So right now, if I add them together, nothing's going to cancel out. I'm going to get a 9x and a 4y equals 12, and that doesn't help me because I don't know how to solve one equation with two variables. So I need to make two of the coefficients be additive inverses of each other. You know, additive inverses like 5 and -5, when you add them together, they cancel out to 0. So what I'm going to do is I'm going to multiply one of the equations through all the way by -1. And when I do that, I'm going to have this 6x plus 2y equals 6, but the top equation is going to look like this. -3x minus 2y equals -6. And now I can add these two equations together. So I'll get 3x, those cancel, and that'll equal 0. Solving for x will tell me that x equals 0. Now, I can take any one of those three equations and substitute 0 in for x. So I'll do it to the first equation just because the coefficients and constants are a little smaller. So go 3 times 0 plus 2y equals 6. If you didn't catch that, oops, now I want the eraser, excuse me. if you didn't catch that, I'm taking this equation right here and substituting 0 in for x because I found out that x equals 0. So this is going to turn to 0. I'm going to have 2y equals 6. Now I know that y is going to equal 3. So the two lines intersect at 0, 3. Okay? All right. Now, they do get a little more complicated. I could multiply through by -1, but I don't have to do -1. Sometimes I can do a different number. I look here, multiplying through by -1 won't help. But I notice that if I multiply the second equation through by -2, that will cause my second equation to become -2x plus 2y equals 2. I'll have a positive 2x in the first equation, a negative 2x in the second equation. So that's what I'm going to do. Okay, so let's see what I get here. I'm trying to keep the colors consistent so you can tell what's going on. All right. These will cancel. I'll get -2y equals -4. Dividing by -2 will tell me that y equals 2. Well, now I got to go looking for x. So I think I will use that first equation. I'm going to erase my work here. Please don't ever erase your work. I'm only doing it for space in the video. Okay. I think I'm going to use that second equation. And I'm going to write x minus 2 equals -1. So that's the same as x minus 2 equals -1. I'll add 2 to each side to find that x is going to equal +1. The two lines will intersect at 1, 2. All right, number 4. Nothing matches. I want you to pause the video and see if you can think of a way that you could get them to match. Okay? Think about it. Take a minute. Try something. Hopefully you've paused the video and thought about it. All right. If I multiply the top equation by 3 and the bottom equation by 5, I'll have a -15y here and a +15y there, and I'll be able to add and cancel out. Some of you might have thought, what if I multiply the first equation by 2 and the second one by 3? Well, then I'd have a 6x and a -6x, and those will cancel. I don't know which one is easier in your opinion. I think I'm going to eliminate my x variables because multiplying by 2 and by 3 will yield smaller results than if I multiply by 5 and 3. So I'll do the top equation by 2, the bottom one by 3. And so my top equation will now look like this: 6x minus 15y, and that's going to equal 8. My bottom equation will be a -6x plus 9y, and that'll equal 6. Now I can add my two equations together. And when I do, I get a -6y equals 14. All right, going to divide by -6, going to divide by -6, which means y, and I'm going to simplify. That's going to be what, 7/3, and that's negative, which is a -2 2/3. Okay, so again, don't you erase your work. Now I'm going to substitute -7/3. You know, I like to report the answer -2 2/3 because it makes more sense in terms of a graph, to me anyway. But when I substitute, I like to use the improper fraction. I'm going to substitute it into the second equation, the second original equation for y, because I see that the 3's will cancel out, and that'll make things a little bit prettier. So I'm going to have a -2x plus 3/1 times -7/3, and that will equal 2. So I'll have a -2x. If I come here, the 3's are going to cancel, leaving me with a -7. That'll equal 2. I'll add 7 to both sides. Now I'll have -2x equals 9. Divide by -2. So x is going to equal -4 1/2. So the two lines will intersect at -4 1/2, -2 2/3. Okay? All right. I'm not going to do number 5 yet. You're going to do number 5. I want you to try it on your own. Okay? You should pause the video, give it a shot, and then once you're done with it, watch and see my solution. Okay, here comes my solution. On number 5, I think I'm going to choose to multiply the top equation by 3 and the bottom equation by 2. Now, by the way, if I needed to, I could have multiplied by like a -3 or a +2. In this case, that would be silly because it would change signs that I don't want to change. Okay, so my top equation is going to look like this: -12x minus 6y equals 60. And my bottom equation is going to be a +12x, that's cool, I like that, plus 6y, and that's going to equal 38. Okay, that's very interesting that that just happened. I wasn't expecting that. These are going to cancel, but so are these. What's left on the left-hand side? Well, 0. And on the right-hand side, I get 98. All right. Well, 0 never equals 98. This has no solution. There is no solution. And I don't need to continue. Had I got an infinitely true statement like 0 equals 0, then I would have had infinitely many solutions, right? Because I got a statement that's always true. Infinitely many solutions. But in this problem, I found that 0 equals 98, which is a total lie, never happens. So I know there's no solution. Okay, so at this point, you should go ahead and do the homework. Now, I know some of you are going to feel insecure and go, well, I don't get it, I don't get it. The reason you don't get it is you haven't tried yet. The understanding comes from the doing. So you need to do the homework. You need to do it now, not a week from now. Like if I don't put these scores in for a couple of days, that doesn't mean you should go, oh crap, I didn't do my homework, and I'll hurry up and do that. There have been people doing that. You need to do it today. Start it now. Get it done this weekend if you need more time. Use the homework help. If you need to, go to Khan Academy. Watch a video on elimination. Hopefully my back will be better and I will be able to be with you Monday and get back to normal and help you out. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.